Okay, so I've just finished the lecture on orthogonality. The principal thing to take away from this lecture is that the four fundamental subspaces pair off into orthogonal complements. On the left side of the figure, we have the null space, which is orthogonal to the row space. And on the right side of the figure, we have the left null space, which is the orthogonal complement of the column space. There's not a ton I have to say here in terms of numerical calculations. However, what we can do is we can codify what it means to sort of study the orthogonal complement of a vector space. So here I have some code pre-written, and the idea is that if you input a basis of some space we're working with, maybe called V, so here I have a list of two vectors which give me a basis of V, the code here will put those vectors into the columns of a matrix. And let's say that somebody asked us for a basis of the orthogonal complement of V. Well, what we know we're looking for in that situation would be a basis of the left null space of that matrix. And this code just automatically does that. So if I click evaluate here, there's two print statements. One tells me what I've input. So this is telling me that the vector space V I'm studying is spanned by the columns of this 4x2 matrix, which makes sense because I input two vectors with 4 coordinates as my basis of V. And then what this is saying is that V perp, so the orthogonal complement of V, is spanned by the columns of this new matrix. So here the thing to notice is that the basis of the orthogonal complement consists of two vectors, and if we look at these two vectors, we realize that they're both orthogonal to the original basis vectors I input for V. So if we're ever studying some vector space V and we have a basis, and we're curious what the orthogonal complement looks like, this code should help.